The name of our group is easy to remember, MESSI. This acronym stands for Microenergy Sources and Sensor Integration. We deal with miniaturized devices that can work either as sensor or as a microenergy source, and on occasions combining both concepts as self-powered sensors. What we do is to exploit micro and nanotechnologies for fabricating those sensors or energy sources. In the field of sensors, we work mainly with devices that can sense gases or biological fluids. In the case of energy, we work with two types of devices. On the one hand, small-size alternative batteries and fuel cells, and on the other side, energy harvesters, that in our case can be based in thermoelectricity, taking advantage of waste heat in the environment, or based in piezoelectricity and triboelectricity, that take advantage of mechanical or energy-related movements. For those sensors and energy sources, we target the integration of materials, nanomaterials, into devices and systems that can be fabricated in large quantities at a low cost, using scalable technologies in when possible, abundantly available materials. This is why we work with silicon technologies or printed technologies or the hybridization of both. Regarding energy, what we want to make first is to power the sensors, and second, to empower them with the right amount of energy autonomy. In the end, these sensors with long, medium or short-term autonomy will find accommodation in industrial, environmental or health applications. We are mainly talking about Internet of Things scenarios and the trillions of sensors they may involve. So our main contribution is to reduce the number of batteries these sensors need. How? Using, for instance, energy harvesters. This will help to solve the huge logistical and environmental problem that replacing and disposal of these batteries may entail. When we produce batteries, we conceive them as self-powered sensors that can fit on the sweat or the blood you want to test. And if they are developed for primary sources for independent sensors, we try to have in mind circular economy concepts and eco-design, for instance using biodegradable or compostable materials. We think that the network can help us to improve the societal visibility of what we do and why we do it. It can also help us to better ingrain ourselves in the local and regional value chain so that our research and technological transfer capabilities can be better exploited in this particular technological domain. And regarding the tools they offer for bringing the research to the market, for sure we want to explore how complementary they are with whatever we may have as a CSIC institute.